All right, everyone, welcome to Notes on Specific Gravity and Magnetism, our final note on minerals. So, specific gravity, this is a ratio comparing the weight of the mineral with the weight of an equal volume of water. So, yep, that's right. This is a ratio. In other words, math. Now, before you start screaming, math, and start running towards the hills, don't worry. It is math and it is a computation, but it is a really, really simple calculation. Okay? So don't freak out on me here. So basically, specific gravity is the density of the mineral. And we use water, well, besides the fact that it's extremely common, found just about everywhere, because most minerals would be difficult to calculate the density using geometry. So, if all minerals came in cubes, it would be really, really easy to calculate the density. But they don't. They come in weird shapes like this. So try to get your ruler in there to calculate every little last nook and cranny to find the volume. Yeah, I don't know about you, but I definitely wouldn't want to do it. Plus, water does not hurt most minerals. While there's a few that does, namely salt, uh, most of them will not dissolve in water. And I'm sorry, if you're dumb enough to put a salt sample in water, you deserve to have it dissolve on you. Okay? So, what you do is you weigh your sample outside of the water. Then you put your sample inside the water. That sample takes up some space. The water goes up. And you can then calculate how much water your mineral was moving out of the way. We call this displacement. How much water would have been taken up by the area that your mineral is taking up. Okay? So it's the weight of the mineral divided by the weight of an equal volume of water, or weight of mineral divided by weight of water. So, for example, a sample weighs 9.925 ounces. The weight of water it displaces is 2.5 ounces. So 9.925 ounces divided by 2.5 ounces equals 3.97 specific gravity. Note, I say here specific gravity because these units here, they cancel. They go away. Bye. Leaving a unitless number, and that is specific gravity. It does not have a unit of its own, it just is a number. Okay, and in this case, looking at the specific gravity chart, we find that it is the mineral known as topaz. Now, don't worry about it being that complicated. This is will be look more like what I would give you on a test. So the sample weighs 9 ounces. The weight of the water it displaces is 3 ounces. So 9 divided by 3 is equal to 3 specific gravity. Okay, I like to keep it simple on tests because I don't want to hand out calculators because that would be annoying. Okay, so hopefully you can do simple division along the multiplication tables. Okay, your eighth graders, I have faith in you. Okay, and this, of course, is the mineral known as nephrite, better known as jade. So, you try it now. We have a sample that weighs 28 ounces. The weight of the water it displaces is 4 ounces. So, do the math. Pause the video and try to do the math and unpause it to see if you're right. Okay, let's take a look and see if you got it correct. We have 28 ounces divided by 4 ounces gives us a specific gravity of 7. And that means that our mineral is the mineral galena, which is actually the primary ore of lead. Now, you can actually sort of feel this by what we call heft. It's how heavy does the mineral feel. Anything under 2 feels light. It's almost like it's not there. 2 to 4.5, it's about average. If you went out to the street and just grabbed a rock, it would probably fall within this range. Above 4.5 feels really heavy and probably contains metal, which is why it's so heavy. It also would probably hurt quite a bit to get hit in the head with. Okay? The smallest specific gravity that we know is heartite, which is a carbon-based mineral at 1.05, and the largest specific gravity is iridium at 22.7 specific gravity. Now, the last property we must talk about is magnetism. Basically, if you take a magnet to a mineral and it is attracted to it, that means that you've got some iron in there, which you might know already. But there actually is a mineral, one, that is a magnet. That's right, you have places where you can literally go around and pick up off the ground a natural magnet. And that mineral is called magnetite, which kind of makes sense. Also known as lodestone. This is very important actually to the history of the world because early compass needles were made by using lodestone. So the Vikings loved it because they used it to help travel the seas. So here we have a little video clip which will show you that's magnetite on a pedestal. And you can see it's being attracted by the magnet there, spinning around. Okay. And that's it on minerals. That's all you need to know. So good luck and study for a quiz later on. Okay. See you guys later on the next notes. Time for rock.